Homework 7 is graphing rational functions. So we've got a multi-step process here, 5 steps to be exact. We are going to start off with number 3. So the first step of this process, if necessary, you're going to simplify the function down. So simplifying usually means see if there's any factoring and canceling that you can do. So this one, the numerator, it's a quadratic, so we'll see if that factors down. So multiplying to 10 and adding to 7, that would be positive 5 and positive 2. So you can see that multiplies to 10, but if you add them, you get 7. And since the denominator is also an x plus 5, we'll be able to cancel those out. And so we end up with an x plus 2 as our function. All right, so we've got that. Step 2, find the x-intercept by setting the numerator equal to 0. So this is the numerator. The denominator, all you have is a 1, technically. So our x-intercept, we are going to take this x plus 2 and set it equal to 0. So to simplify, we would subtract 2 from both sides. So we get negative 2. So when I write it over here, make sure you're always writing your x-intercept as an ordered pair, because intercepts, both y and x-intercepts, are ordered pairs. Step 2, find the vertical asymptote by setting the denominator equal to 0. So here, there is no denominator. There's just a 1. So if there is no denominator, then there is no vertical asymptote. All right, so we would just say that there's none when we ask for a vertical asymptote. There is none. Step 4, the horizontal asymptote. The rules that you've got in your notes, those are always going to be a little tricky. Just follow through based on the degrees. So this one, since the denominator is technically a 1, that's just a number that has no degree. That's just a degree of 0. So the numerator has a degree of 1. The denominator technically has a degree of 0. So that category is the numerator has a larger degree than the denominator. So if the numerator has a larger degree than the denominator, our rule says that there is no horizontal asymptote. So we've got no vertical, no horizontal. All we have so far actually is this 1 point right here, an x-intercept. Step 5, identify any holes in the function. Okay, so holes are going to be based on what your common factor was. Okay, so we did have a common factor and that common factor canceled out, so we are going to have a hole. So for the x-coordinate, you're going to set the common factor equal to 0. Okay, so let's make a little side note here. You're going to take that common factor and you're going to set it equal to 0. So the x-coordinate is a negative 5. And then for the y-coordinate, you're going to substitute the x-coordinate into the simplified function. Okay, so this negative 5, you want to sub it into the simplified function. So y equals negative 5 plus 2, which comes out to be a negative 3. Okay, so these 2 points become an ordered pair. So there is a hole at negative 5, negative 3, like that. All right, so plug the 2, 3, 4, 5 down to negative 3. So you're going to have a hole there. And then the rest of it, the x plus 2 is just a linear function. It's a linear function that has a y-intercept of 2 and a slope of 1. So we can just connect the dots here, kind of start at the value of the hole, and then you just don't include the hole when you're writing down your domain and range. So domain and range is any x values, you just start to exclude values of any vertical asymptotes and any holes. So the hole value you cannot include, so that's a negative 5. So for the domain, it can be anything except for any vertical asymptotes and any holes. So there is no vertical asymptote, so all you would exclude would be that negative 5 from the hole. And then the range is the same, except it's the y value. So for the range, it's any y value except the horizontal asymptote or the y value for the hole. So y can be anything except there is no horizontal asymptote, so just that y-coordinate from the hole. All right, so that is our first example. Let's do one on the back page. Let's do number 5. All right, so number 5, simplify it. So this one, the numerator, you can factor out a GCF. So when you factor out that x from the numerator, you have an x plus 4 left behind. The denominator is another quadratic that you can factor. So start with x times x. So you're looking for what would multiply to a negative 4 and add to a positive 3. So that would be plus 4 minus 1. So this you'll be able to reduce down those binomials that match. So we can cancel these out, and then our function reduces down to just x over x minus 1. All right, so we've got all of these pieces that we can find to the exact same step that we just used for the one on the front. So x-intercepts, you are going to take just the expression that is in the numerator, and you're going to set that equal to 0. So that's actually it, because you've got x equals 0. So that's just the origin. So we have 0, 0, so you can go ahead and plot that point. And then the vertical asymptote you would get by taking the denominator and setting that equal to 0. So here I do have a denominator besides just 1. So I'm going to take x minus 1 and set that equal to 0. So add 1 to both sides. We get x equals 1. So that is a dotted line that I'm going to plot in as a vertical line. So x equals 1 is this line right here. For the horizontal asymptote, this is the step that's a little tricky. You've got that set of 3 rules that you have in your notes. So compare the degrees. So here, this has a degree of 1, this has a degree of 1. So if the degrees are equal, you just look at those leading terms. All right, so we have x over x. So this is just a 1 over 1. So 1 over 1 just reduces down to 1. So that is our horizontal line that we can plot in right there. So that's, I think the horizontal asymptote is going to be the rule that's going to be the hardest to understand. But just look back at your notes. You've got 3 scenarios based on the degree of the top and bottom. Next, last step is our hole. So the hole is a little bit tricky too if you have one. This only applies if you had something that cancels out here. So for the x coordinates, you set the common factor equal to 0. So the common factor is x plus 4. You set that equal to 0. So when I subtract 4 from both sides, I get negative 4. So that turns into the x coordinate for the hole. All right, and then for the y coordinate, you take that x coordinate and you sub it into the reduced version. So we have y equals negative 4 over negative 4 minus 1. So that would be negative 4 over negative 5 or positive 4 over 5. So that turns into your y coordinate, which you can then plot. So we have a negative 4, 1, 2, 3, 4, and then up at 4/5, so just like basically coming right up to that line right there. Okay, so that would be your point that you plot. Domain and range, you're just excluding vertical asymptotes, horizontal asymptotes, and holes. This one, a lot of these, you want to just kind of take a quick glance at what a calculator would look like. You can plot a couple of additional points if you want to. So this one, for number 5, you've got just this kind of normal reciprocal type of function curve. So you could go along these dotted lines through these 2 points and then down along this vertical asymptote. And then this is just the reciprocal of that graph on the other side. But like I said, use Desmos, use a graphing calculator. If you're unsure of what the rest of the picture should look like, take a look at the graph. All right, so this will just kind of do the exact same thing and come right in along here like that. Okay, so for the domain, exclude the vertical asymptote as well as the value of the hole. So x cannot equal a negative 4 or a positive 1. Whoops, this should have been plotted as a hole. Sorry, not a point. That point right there is the hole, so that should be open, not closed. The range, you exclude the value of the hole and the value of the horizontal asymptote. So I can be anything but a positive 4/5 or a positive 1.